Hello and welcome back. In this short video, we're going to take a look at the ray diagram for an object placed in front of a diverging or convex mirror. We're going to start with the object being placed very far away from the mirror, and then we'll move it to what would be the opposite to the center of curvature, and then the opposite to the focal point, okay, and then really, really close to the mirror, halfway in between. Okay, now you'll notice since the curvature of the mirror is curving away from you, the center of curvature is now over here and the focal point is halfway over on the inside of the mirror. Okay, so make sure we understand the focal point is over here, not here. Now, when parallel rays strike a convex mirror like this, they always bounce away from it. Okay, it's the opposite to a concave mirror. When light strikes a concave mirror, it always reflects inward towards a focal point. And that should make sense because the curvature happens this way, center of curvature here, focal point halfway. Okay, so with a convex mirror, light is going to be bending upwards or downwards, but away from the mirror itself. And the focal point is over on the other side, inside the mirror. The rules are the same. The first ray is going to go parallel to the principal axis. Remember, I'm using my incident ray as black, my reflected ray as blue, and my back ray as gray. Make sure you draw a back ray for every reflected ray. The first ray goes parallel to this thing called the principal axis, which bisects your mirror, and it's going to reflect upwards. Now, it's going to reflect upwards. I want you to take your paper and reflect it up in such a way that it's bending away from the focal point. See the focal point right there? It's going to bend away from the focal point, upwards at an angle like this. Draw that so that your straight edge should lead you to drawing the back ray right back through the focal point. So now it's the same rule, parallel to the principal axis through the focal point, but it's not the reflected ray going through the focal point, it's the back ray which goes through the focal point. There's ray 1. Ray 2 tries to go through the focal point. I want you to line up the focal point with the top of the object like this. But as soon as you hit the mirror, right there, I want you to back up and reflect it parallel. The second ray goes through, or in this case, the second ray is trying to go through the focal point. It doesn't reach the focal point because, of course, the focal point is on the other side of the mirror. But it tries to go through the focal point. Once reaching the mirror, it reflects parallel. And you can see the back rays have intersected right in front of the focal point, producing an image that is upright. We can see it's a right side up arrow. So an upright image. It's reduced. You can see the size of the arrow is smaller than the original object. And it is a virtual image because it is produced behind or inside the mirror. Number 2. Now we move it a little closer. Parallel to the principal axis. We are going to reflect up at an angle such that the back ray goes back through the focal point, like that. Make it nice and long. The second ray desperately tries to go through the focal point, but doesn't reach it because there's a mirror in the way. And as soon as we get to the mirror, we're going to reflect it parallel. Draw your back ray. Okay, a couple of things that you should see happening here. One, as we get closer to the mirror, the image is getting closer to the mirror. We should be noticing that. The other thing we should be noticing is as we get closer to the mirror, the object is still upright, reduced, and virtual. That part didn't change. But what has changed is the fact that the image itself, as you get closer, although it is a reduced size image, it is itself the image getting larger. Number 3. Now we're halfway between the center of curvature and the focal point. parallel to the principal axis, reflect in a way that is opposite from the focal point, draw a dashed line going through the focal point as your back ray. Second ray tries to go through the focal point, tries, gets to the mirror, it's denied. Reflects parallel. We have an image that is upright, reduced, and virtual. What happens when we're at the point that's opposite to the focal point? Before, we had no image formed. So in this case, we're going to go parallel to the principal axis. We're going to go up in such a way that we're going opposite to the direction of the focal point. Draw a back ray through the focal point. Your second ray goes or tries to go through the center of curvature, through the focal point. As soon as we reach the mirror, it's going to bounce parallel to the principal axis. When we draw the back ray, we can see the image is forming even closer. We still, notice, have an upright, reduced, virtual image. And lastly, let's take a look. We're moving halfway between the focal point and the mirror. We're going parallel to the principal axis. You're bending up at such a way that your back ray goes back through the focal point. Your second ray is trying to go through the focal point. It doesn't quite make it. It hits the mirror and reflects parallel. Still producing an upright, reduced, virtual image.